everyone, welcome. Today we're going to be talking about translating the absolute value function. Translating essentially means shifting vertically or horizontally, at least as far as we'll be dealing with in Math 2 with the absolute value functions. So by now we should all be familiar with our parent function, y equals the absolute value of x. Y equals the absolute value of x looks like this graphically. But what if we were to shift this graph around? There are many things that we can do to this graph. We can shift it vertically, we can shift it horizontally. So let's take a look at our generic equation of the absolute value function. Here we have y equals the absolute value of x minus h plus k, where our vertex is located at h, k. By looking at this equation, we should immediately be able to tell where our translations are. By looking at this equation, I can find my horizontal shift, and I can also find my vertical shift just by looking at the equation. And as we look at these more and more frequently, we'll be able to look at it and be able to verbally explain exactly what each graph is doing. With these types of problems, there are a few things that can be a little bit confusing. The first, we'll start with the horizontal shift. This graph tells us that we will be going to the right h. And this is a little bit counterintuitive because we look at this and we can see the negative sign. So instinctually we'd say go to the left h units, but it's actually go to the right. Next, we can take a look at our vertical shift, and this is telling us to go up k units. So this actually makes the most sense because we look at it, we see a positive value there, it tells us to go up. For the horizontal shift, we look at it, it looks like we're subtracting a value, so it looks like we should go left when in actuality we should go right. So let's take a look at an example. Here we have an equation, y equals the absolute value of x minus 3 plus 2. So looking at this, we should be able to find our horizontal shift and our vertical shift. So what that tells us is that this graph will be shifted to the right 3 and up 2. So what does this mean for our graph? Here we can take a look at the parent function, which is in orange, of y equals the absolute value of x. Here we know we're shifting it to the right 3, and we're also shifting it up 2. All right, so here is the graph of y equals the absolute value of x minus 3 plus 2. You, however, are not going to have the luxury of being able to grab a graph and slide it around on your paper. The key here, when we're translating absolute value functions, is to identify where our vertex is. In this case, we know it's at 3, 2. We can plot that point on our graph and sketch our absolute value graph from there. Notice it's not drawn completely to scale there. It is just a sketch. Let's take a look at a slightly more complex problem, and we're going to introduce another wrinkle, which is a reflection. The reflection is over the x-axis, and you can always tell when an absolute value function will have a reflection if there is a negative sign in front of the absolute value. The horizontal and vertical shifts are still located in the same place, although it is a little bit trickier to identify the horizontal shift in this situation. If we were to look at this equation, we know the format is x minus h inside these absolute value. So in this case, we can rewrite this as x minus a negative 5. And that's where the plus 5 comes up in this equation. So looking at it, it's not a shift to the right, but it is a horizontal shift to the left 5. The vertical shift is also a little bit different, but it's not that tough to identify. It is a vertical shift down 1. So in this graph, we have a reflection over the x-axis, we have a horizontal shift to the left 5, and a vertical shift down 1. So what does this mean for the context of our graph? All right, once again, we start off with our parent function. All right, we know that it's going to have a reflection over the x-axis. So where our parent function has a V-shaped graph, the shape of our reflected graph is going to have an upside down V. So there's the reflection over the x-axis. We also know that we're going to have to shift our graph to the left 5 and down 1. So this is now the graph of y equals the negative absolute value of x plus 5 minus 1. Once again, you're not going to have the luxury of just sliding your parent function around on your paper, so you're going to have to plot the vertex point, in which case it is negative 5, comma, negative 1. And we're going to have to identify that there is a reflection here. So where the graph would normally be a V-shaped, it is now an upside-down V-shape. Try to do this problem on your own.